Thank you very much for the introduction. It's an honor to be here with you all, as well as the Magaldi team. We've been working with Magaldi for a couple of years now, so that's really cool to be here and see what they've developed. So today I'm just going to talk a little bit about thermal energy storage technologies, where they've been, where they're going, and what we can expect in the coming years. Go next. You can go to the next slide. So, thermal energy storage, I assume everyone in this room is pretty well aware of what technologies are out there, but I think it's always useful to just start with a high level overview. So, in thermal energy storage, there's different forms: sensible, latent, and thermochemical energy storage technologies. The technology we're sitting in front of today is a sensible heat storage, where we heat up a media and we store that energy as something that is essentially hot to the touch. Um, Within these different categories, you can store energy in different medias. Here, we're looking at a system that utilizes sand as a storage technology. But from many of us who've been at SolarPACES, we're also well aware that liquids like molten salt or sulfur or other media types can be used for thermal energy storage. I'll highlight something that I think is really unique about thermal energy storage technologies, and that is its ability to be charged and discharged with either heat or power. So, being born essentially in the CSP industry, traditionally thermal storage technologies have been charged with a thermal source rather than electricity. Um, and in recent years, we've seen this transition to the charging capability with electricity to account for the excess renewable generation of wind and PV, as we've heard much about this morning. You can go next, please. So I wanted to focus this talk on solid media thermal storage, just because that's the technology we're putting in the spotlight today. So some of the advantages of this style of energy storage are that it can be very high energy density when you store it at a high temperature, such as 620 degrees Celsius, like we have here. The storage media is typically low cost, so the sand, concrete, gravel, rocks, things of that nature, fairly abundant and fairly low cost. It has a low carbon footprint, and many of the supply chains are already existing. We're not sourcing rare earth elements, and we're utilizing predominantly off the shelf hardware. So there's a variety of technology players in this space. Of course, we're here, celebrating with Magaldi, but there is a number of other technology providers out there, and their technologies span a range of test configurations. So, for example, you might have folks working on fluidized bed storage, like we have here, static bed, pumped thermal energy storage, moving particle thermal energy storage, and a litany of other configurations. So, compared to other energy storage technologies, there's really a broad subset of technologies that you could categorize as thermal energy storage technology. I just want to highlight a few benefits of test technology. The first, I think, is we've covered pretty well. It can be used for decarbonizing industrial process heat, but it also will have applications in the grid storage space for electricity. If we look at a specific type of thermal energy storage technology on a capital cost basis, it can be very competitive with lithium ion solutions. So here we're looking in an instance where we've accounted for a system that would deliver electricity to the grid. And we see that the thermal energy storage technology shows promise for being a lower overnight capital cost. If we consider the lifetime cost and we look at an LCOE scenario and we assume a system of 40% round trip efficiency, we can see that we can be fairly competitive with lithium ion technologies depending on how you set the system up. So I had a few animations here, but I see I don't have the ability to flip through those. But the dashed green line represents a thermal storage system that has the same charging and discharging power compared to an equivalent lithium ion battery system. And so what we see is that it can have a lower levelized cost, but at fairly low percentages of the load you're trying to meet. So not meeting a very high percentage of that load. But what we've seen is that if you have the ability to asynchronously charge and discharge your system, so you could charge very fast or with a lot of excess renewables, you can deliver a much lower LCOE than lithium ion systems over a much broader range of the load that you're trying to meet. On the thermal side, very relevant to industrial process heat, you can see that the costs of the system on a capital basis come way down. There's a couple of reasons for this. Predominantly, the fact that you remove the thermal to electric conversion equipment from the system. This is oftentimes the most expensive component in a thermal storage technology. And so by removing that, you drastically reduce the cost of the equipment. So then when we go ahead and look at this over the lifetime, you can see now our similar comparison here to lithium ion, but looking at the energy delivered as heat, you can see it's a landslide towards thermal energy storage technologies, showing favor for cost and being competitive with the existing fossil resources. So the last slide that I'm going to go through, I think whoever's flipping the slides, I have a couple more in there, but we'll just stop on this last slide. The last benefit is the footprint. So this nice big box right here, yes, it is fairly large, but there is a relatively high amount of energy stored in this container. And you can see that it's fairly tall and you can stack it quite high. If we compare a thermal storage technology on the American football field here, it's a couple stories tall, up to around 15 meters in diameter. Whereas if you looked at a 1 gigawatt hour equivalent of a Tesla Megapack or a lithium ion battery, you can see it takes up much more land area. And if you're a battery aficionado in the room, you might be looking at my layout here saying that is surely going to catch on fire. And it surely would. So it would actually take up much more land than that. And then, of course, pump storage hydro, we heard about this morning. It is largely deployed. It is a great technology, but you're geographically or geologically constrained. You need a large reservoir of water and you need a mountain to store that water on. So just to kind of speak to one of the less emphasized benefits of thermal storage technology. So with that, I'll stop there and I appreciate everybody's time. Thank you.